If the moon suddenly vanished from Earth's orbit, the consequences would be both immediate and catastrophic, fundamentally altering our planet's physical systems and potentially threatening life as we know it. Within hours of the moon's disappearance, Earth's tides would dramatically diminish to barely perceptible rises and falls caused solely by the sun's weaker gravitational influence, reducing tidal ranges from their current averages of several meters to mere centimeters. This tidal collapse would devastate coastal ecosystems worldwide, as countless marine species, from tiny amphipods to massive whales, depend on tidal cycles for feeding, breeding, and navigation, while intertidal zones that support extraordinary biodiversity would essentially cease to exist. The moon's absence would destabilize Earth's axial tilt, which currently remains relatively stable at 23.5 degrees due to lunar gravitational influence. Without this stabilizing force, our planet's axis would begin to wobble chaotically over thousands of years, potentially varying between 0 and 85 degrees. Such dramatic axial shifts would trigger extreme climate variations, alternately plunging regions into permanent winter or scorching summer, making long-term climate patterns unpredictable and likely uninhabitable for most current life forms. Earth's rotation would gradually accelerate without the moon's tidal braking effect, shortening our days from 24 hours to approximately 6 to 8 hours over millions of years, creating violent weather patterns as the atmosphere struggles to adapt to rapid day-night cycles. Ocean currents, currently driven partially by tidal forces, would reorganize dramatically, disrupting the global thermohaline circulation that regulates planetary temperature and weather systems, potentially triggering new ice ages or unprecedented warming periods. The psychological and cultural impact on humanity would be profound, as the moon has served as humanity's timekeeper, calendar, and inspiration for countless myths, religions, and scientific endeavors throughout history. Agricultural cycles, many of which have evolved around lunar phases, would require complete restructuring, while nocturnal animals that rely on moonlight for hunting and navigation would face extinction. The night sky would become significantly darker, revealing more stars but eliminating the gentle illumination that has guided human civilization for millennia. Interestingly, the absence of the moon might accelerate certain aspects of human development, as the lack of tidal forces could make coastal engineering projects more feasible, while the increased visibility of stars might spur astronomical discovery. However, these potential benefits pale compared to the existential challenges posed by climate instability, ecosystem collapse, and the fundamental disruption of planetary systems that have remained constant throughout Earth's biological evolution, suggesting that while humanity might adapt to a moonless world, the transition would likely represent one of the most challenging periods in our species' history, requiring unprecedented global cooperation and technological innovation to survive the radical transformation of our planetary home.